Hello everyone, this is Dr. V.V.Kamesh, Professor of Mechanical Engineering, Aditya University, Surampalem. In this lecture, we would like to know about how to draw cam profiles. At the end of this lecture, student will be able to explain about displacement, velocity and acceleration diagrams under the condition follower moving with uniform velocity. So, this is one of the nomenclature in radial cams. So, we are having the different types of the cams. One of the important one is radial cam. In this radial cam, always you are having cam attached with follower. So, based on the cam design, that is the outer surface, the follower will move in a different displacement, velocity and acceleration, that we will discuss later. So, the radial cam means whenever you are having the radial, by the rotation of the shaft and the cam is attached to the shaft, then the contour of the cam will be having different ups and downs or some irregularities. In a normal language, you can say the irregularities on the cam, that is making the follower to move in a direction like this, right? So, here suppose I am moving this pen as a follower. Suppose there is a circle here, let it be some shaft, right? Suppose this cam, this follower is attached to the shaft. Think that the shaft itself is the cam, right? So, if it is rotating in a circular way, the follower will not move at all. Whenever there is some obstruction, the follower may move down or up. Now, we need to decide how to move this, right? So, these are the different elements that are in the cam profile. Actually, this is what we are having the shaft. I am making with the green color. So, this is actually the shaft which we will have. On this, we need to make the cam to support it. Okay, so this is actually the key which is used to rotate, and primarily the cam profile is to be drawn with base circle. So, surrounded with the shaft, we are having a base circle, right? So, next to the base circle, we are having prime circle. This is actually the camshaft, and this is okay. We will discuss about the pitch point and pitch curve after the cam profile is drawn, right? So, regarding the maximum pressure angle, trace point, everything we will discuss later, because initially we need to start with the displacement, velocity and acceleration. So, in this diagram, first you need to identify, this is the reciprocating follower, some color, okay. I am giving the cyan color for the follower. So, this is the roller follower. So, I am giving the pink color for this, okay. Now, you can look it. Now, you can observe very carefully, suppose this is the cam I am having. On the right side, I had drawn with the green color with some irregularity, and I will attach some follower like this. So, this is the roller follower I am taking, right? And here I am having the shaft is mounted like this, and the cam will be mounted, okay. So, this is my shaft and this is my cam, and I am rotating, right? Suppose I am rotating anti-clockwise like this. Now, you observe just only the movement of this roller. So, we need not worry about what is the follower, how it is moving. Initially, you observe only the roller, right? But roller is attached to the follower, and the follower is bound to move in vertical direction only. So, I am bounding this follower and roller, right? So, the roller will be attached to the cam only for the instance. At that instant only, the cam is attached to the roller, right? So, cam will be moving, that means rotating like this, and the follower being attached with the roller, right? Follower directly not attached to the cam, it is attached through roller, right? Now, the roller motion followed by the cam followed by the roller, right? So, when the cam is rotating, the roller has to respond because it is directly attached to the cam. Now, what is the motion of the roller, right? So, cam is rotating anti-clockwise in this diagram. So, the roller will have up and down motion only, okay, because it is bound to move in, what is the bound to move in? Vertical direction only. Now, you can see these are the stoppers. Roller attached to the straight follower, it has to move only in up and down direction, vertical moving. That's what in the diagram it is given, total follower travel, that will be in vertical direction, right? Now, at this point, the roller will be here. Suppose the contour of the cam, that is having some irregularities, right? Due to the irregularities, at one point of time, roller will be here, at another point of time, roller will be down, At another point of time, roller will be again up, right? So, the instance of the roller movement that is causing the follower to have a definite motion defined in different ways, right? So, this up and down motion, how it will be? If it is following a pattern, then we can classify the movement of the follower with pattern 1, pattern 2, pattern 3, pattern 4, pattern 5 like this, right. Now, this is actually the motion of the follower. During its travel, the follower may have one of the following motions. That means we are clearly saying there is a particular pattern for the follower. How many different possibilities are here with us? Uniform velocity, uniform acceleration or retardation, simple harmonic motion and cycloidal motion. These four are the different movements that can be enabled for follower, right. Other than this, if the follower is making some other movement, it can be, we need not classify in this, we can call it as random movement. So, there we cannot predict exactly according to the mathematics what could be the velocity of the follower, what could be the acceleration, what could be retardation, right. So, if the follower is making one of this, first one, second one, third one and fourth one. So, we shall now discuss the displacement, velocity and acceleration diagrams for the cam when the follower moves with the above mentioned motions. Now, initially we will discuss about displacement, velocity and acceleration diagrams when the follower moves with uniform velocity, right. In the left hand diagram, you see this is the displacement diagram with one revolution of the cam, because all the ups and downs from the cam profile from starting point to the same starting point as an ending point, because this is revolving, right. So, with one revolution of the cam, how the moment of your follower will be. Now, you can see the displacement, velocity and acceleration diagrams when we need to discuss these one later. The follower moves with the uniform velocity as shown in the figures. The axis, that is x-axis, represents the time, the number of seconds required for the cam to complete one revolution. Actually, one revolution means 360 degrees. In this 360 degrees, how many degrees will the cam will be following a particular pattern or moment? So, it may represent the angular displacement of the cam in degrees. Suppose in the initial 120 degrees, cam will follow one motion, next to 90 degrees, another motion, next at 180 degrees, another motion, remaining out of the total 360, it may follow some other motion, right. And one more, we are not restricting the moment of the cams to be only 3 moments or 4 moments. It can be as many, but they need to be confined within 0 degrees to 360 degrees. Okay, what is the y-axis? The ordinate represents the displacement or velocity of the follower. Now, initially, we will discuss about the displacement diagram. The displacement diagram, initially, it is having the minimum 3 elements. One is rise, second one is dwell, third one is return. Rise means whenever the starting point of the cam is at the lower level and the counter of the cam is causing the roller or the knife edge to rise, that means it is moving upwards. Rise means the point of contact between the cam and the follower, that is moving up. Basically, the follower is moving up, then it is called rise. Okay. So, the displacement moment, right, slowly, steadily with the uniform velocity, the displacement is moving to a upper direction. That is why we are showing here A to B, right, uniform velocity. Next part, dwell, that means the counter of the cam changed suddenly and it is enabling dwell. That means there is no change in the displacement. That means there is a circular arc on the cam profile. When there is a circular arc on the cam profile, definitely the roller or knife edge will not move at all, right. So, displacement is constant. So, B1 to C1, that means up to some degrees of the cam moment, it will be constant. Now, after this, the cam profile again changed from circular arc to some other profile, right. So, it is causing the down movement of the follower. So, C1 to D, the cam is moving down, right. So, by the time the cam is rising and constant dwell and return, so many degrees of the cam completed. right? Suppose we are having nearly 270 degrees completed, let it be. So D is the point we are having 270 degrees. Now D to E, the remaining point dwell, that means it is coming down or constant, right? After coming down from C1 to D, D to E, it is constant. Whenever you are having the dwell period, dwell from B1 to C1, dwell from D to E, definitely there will be a circular arc on the cam profile, okay? So this is with displacement diagram. Next with the velocity, okay. The displacement derivative is velocity, the velocity derivative is acceleration, right? Now the velocity you can see, the displacement is steadily increased from A to B, that means uniform velocity, right? Now initially at A the velocity is like this, maybe let it be some 5 meters per second, right? So A to B, the follower is moving with uniform velocity. So in the velocity diagram you need to show uniform velocity, right? Now from B1 to C1, right, the displacement is 0. Whenever the displacement is 0, the velocity will also be 0. So it will be 0. Next, C1 to D, the follower is moving down with uniform velocity. So the velocity has to get negative. We are showing in the negative, but because the velocity is uniform and uniformly it is getting retarded, right? Clear? After that, the dwell period. Whenever there is a dwell period, displacement will be 0. The derivative of the displacement will also be 0, right? Next, we are going to the acceleration diagram. Acceleration diagram is actually the rate of change of velocity, right? In the figure, you can see the acceleration is infinite. It is showing infinite, right? Why it is showing infinite? You look at the acceleration or retardation of the follower at the beginning and the end of the each stroke is infinite. Practically it is not infinite, but theoretically it is showing infinite. Why it is infinite? Look at the point A. In the point A, actually the displacement is 0 initially. The time of the instant with the delta t time at the point A to the immediate point with the slight fraction of time delta t, the velocity is becoming some value. Look at this, the velocity. I told earlier, just an example, 5 meter per second, right? With a slight delta t of the fraction of second from 0 meters per second, because earlier the body is at rest. Here the body is follower. When the follower is at rest, immediately, right? Even though we are saying immediately, there is a fraction of minute seconds, delta t, let it be 0.001 second, right? A nanosecond, 0.001 second, let it be very, very minute, right? In that minute time, the velocity has to reach from 0 to some desired, let it be 5 meter per second, right? So, what is the acceleration then? Rate of change of velocity with time, right? So, delta v by delta t. So, what is the acceleration actually? Delta v by delta t. What is the delta v? 5. What is the delta t? 0.001 second. So, what is the acceleration? A very big number, very, very big number, right? So, that is why we are calling acceleration is infinite. So, this is due to the fact that the follower is required to start from the rest and gain to velocity with no time, right? Even though practically it is impossible, so we are taking a fraction of second, let it be for example 0.001 second, right? So, if the acceleration or retardation at the beginning and at the end of the each stroke is infinite, these conditions are however impracticable, right? So, this is actually the ideal displacement velocity and acceleration diagram. Practically there will be some deviation because the engine has to be given some sufficient time, right? Even in automobiles, we are saying this particular engine is getting BHP of 10 or 15 horsepower within 5 seconds, 10 seconds, 15 seconds, like this, right? So, we are pricing that particular automobile based on within a time limit of 5 seconds or 10 seconds, it is reaching high power, right? So, what is that 5 to 6 seconds? It is actually the threshold time, right? But here, according to the displacement velocity and acceleration diagram, it is impracticably within no time the velocity has to rise, right? So, there will be some modifications which govern the motion of the follower, this may be done by rounding up the sharp corners of the displacement diagram at the beginning and at each stroke, right? Whenever there is a sharp edge, within no time I has to rise, but if I round it off, there will be some smoothing of the curve. Then the velocity of the follower increases gradually to its maximum value at the beginning of each stroke and decreases gradually to 0 at the end of each stroke. Now you can have slight variation in the displacement diagram. This is the old one and this is the new one. Now look at your velocity rise here and the velocity rise here. So within very short period of time, the time is given in the x-axis, right? So with a slight, the displacement is slightly moving, velocity is slight, and acceleration, it is having some definite value. So the summary of this lecture is, student can explain about the displacement, velocity and acceleration diagram with uniform velocity of the follower. Thank you.